Okay, last section in Module 7 is complex fractions, which is a fraction over a fraction. So it looks like this. It's a really ugly fraction because it's a lot of lines here. But it's really just, if you write it out like this, we've already done it. Okay, there are going to be some that you're going to have to simplify first, but it's just a division problem. Okay, so you're going to write it out like that, simplify as a normal division problem. So step 1, factor both the numerator and denominator. So on this first one, I can factor that x squared minus 1 to x plus 1, x minus 1. And that's all I can factor. Then I'll keep the first fraction the same. Change to multiplication. Flip the second fraction. So x minus 1 will go on the top, 2 on the bottom. Then I extend my multiplication line. Cross out what I can. What can I cross out here? Yeah. Cross out the x minus 1s. I've got 3 over, we'll put the 2 in the front here, 2 times x plus 1. That's all I can do there. All done. So you might have to, let me see. Yeah, so in the next one we will have to, because there's addition and subtraction in each side of it. So this is just a simple example just showing how to write it out and do it, but then it does get a little more complicated. So let's look at example 2. So when I write this out, it's going to look like this. You've got 1 over x plus 2x over y divided by 1 over x squared minus 1 over x squared y. So the reason why I wrote these in parentheses is because there are operations on both sides of that fraction. So you have to do the operations first before you do the keep, change, flip. Okay, because you can only flip something if there's only one fraction. Here there's 2 fractions, so you have to do the numerator and denominator first by finding the LCD and adding and subtracting these fractions. So good news is I can't factor anything. So this is just adding and subtracting first. So LCD here, you would just need one of each, x and y. Okay, so for this one, you have a common denominator of xy. So the first fraction is missing a y. The second fraction is missing an x. So that's going to give us 1 times y, 1y over xy. Plus, that's going to be 2x squared. And then that's going to be xy. Then I add across the top there. So this is going to be y plus 2x squared over xy. Okay, and that's the most that I can simplify that. I cannot cross these y's out even though they're singular because this y is attached to the 2x squared with the plus sign. Okay, it's by itself there. Or it's not by itself in the top. It is by itself in the bottom. All right, next I want to do this fraction, or this problem. So what is this LCD? So I would want the y. What about the x squareds? I would need that also. So they each have an x squared, so that's part of the LCD. And then you also want the y. So really the only thing that's missing is a y from the first fraction. Okay, the second fraction is not missing anything. So this is 1 times y over x squared y minus 1 over x squared y. So my second fraction is going to be y minus 1 over x squared y. Okay, now we do the complex fraction part where we keep, change, flip. So we would change to multiplication here and flip this fraction here. So this would be an x squared y here, y minus 1 in the bottom. Okay, now it's multiply. So I really just write this all next to each other, right? So I've got the singular term first, x squared y, times y plus 2x squared, over xy, times y minus 1. Can I cross anything out? Yeah, I can get rid of one x here, and this x here, and these y's are going to cancel each other out. Because those are singular, so those can cancel each other out. And I've got x, y plus 2x squared over y minus 1. It is an ugly problem. Doesn't factor or come together very nicely, but that would be the last part. All right, any questions on that one? Let's do this one, and so we got two more. Okay. All right, so in this first one, I do have in the top an addition problem. So I have 8 over x plus 3 plus 12 over x plus 7 divided by 5x plus 23 over x squared plus 10x plus 21. Okay, so let's deal with the parentheses first. Nothing to factor. Common denominator there. You would want one of each factor. So it's going to be x plus 3 and x plus 7. So this one is missing an x plus 7. And then the second fraction is missing an x plus 3. Okay, so we're multiplying by what's missing. Let's go ahead and multiply out the tops. So you have 8 times x plus 7, so 8x. 8 times 7 will be 56. Okay, then the 12 times x will be 12x. 12 times 3, 36. Combine like terms. I'm going to get 20x. 56 plus 36, is that 92? Plus 92. Could probably take a GCF out of that. A 4. And that's going to give me 5x plus 23. Okay, so that's my numerator simplified from here. I'm going to put that over my common denominator, x plus 3, x plus 7. Okay, so this numerator here, the grouping, is now simplified. So now I can divide. But really, I'm multiplying, right? And I'm going to flip this. So this is x squared plus 10x plus 21 on the top, 5x plus 23 on the bottom. Can I factor the x squared plus 10x plus 21? Yes, I can. What does that factor to? Which means this is going to be a nice one, right? X plus 3's cancel. X plus 7's cancel. 5x plus 23's canceled. My answer is 4. We'll do one more, and then I will let you guys try one of them. Maybe two. Alright, oh, this one's singular, so this isn't too bad. So you've got negative 5x over x minus y divided by y over x squared. So you don't have to add or subtract anything from either side, so you would just go straight to keep, change, flip here. So this is negative 5x over x minus y times x squared over y. Can I cancel anything there? No. No, because they're on the same side. This x here is attached to the y, so unfortunately that's one term. So really all I can do here is negative 5x cubed, and then this is going to be y times x minus y. So that one did not come out to a nice answer. No, you don't need to distribute that. You would leave it in factored form. Yeah. All right, let's go. Let me give you. There's one on here that's kind of tricky I want to show you, but I'm going to let you try it first. And it looks like this. Just kind of bringing back prior knowledge with your exponent rules. And then let me give you another one. All right, give those a shot. I don't want to run out of time, so I'm going to start going over these. So, did anybody figure out what you had to do for this first one? Close? Well, it's just 15 over x. So, kind of the same thing, right? Or what did you do 15 plus 1 over x? So it should be times. Yeah. Okay, yeah, so it's like this. 5 plus 15 over x. So then to the negative 1 drops it into the denominator. But you could do times 1 over x. It just ends up being the same thing. And then this would be 1 minus, then that would be 9 over x squared. Okay, so the negative exponent moves the position of the variable. So then we want to take these and we want to add the numerators and the denominators together. So we'll start with the 5 plus 15 over x. which means the common denominator there is just going to be what? Yeah, that's just going to be an x, so we'll just multiply first fraction by x, and then across that is going to be 5x plus 15 over x. Okay, so that is going to be the simplification of this parentheses here. We can go ahead and do the GCF there if we want. That's 5, and then x plus 3 over x, if we take out the 5 as a GCF. All right, then let's go back to 1 minus 9 over x squared. Oop, not 9x squared, 9 over x squared. So that would be a common denominator of x squared. So we would multiply this first fraction by x squared. So then this ends up being x squared minus 9 over x squared. And x squared minus 9 is going to factor to what? Yeah, x plus 3, x minus 3. We'll put that over x squared. Okay, so that is a simplification of this denominator here. So then we're dividing, right? So we're dividing this 5 x plus 3 over x by x plus 3x minus 3 over x squared, which means we're going to multiply, and then we're going to flip this. So the x squared is going to go on top, and we'll have x plus 3, x minus 3 in the bottom. And then we will cancel out some stuff. So we can cancel out x plus 3's. What about the x and the x squared? Yeah, I can pull this. This is x times x, so just one of these x's will go away. So then I'm left with 5x over x minus 3. Any questions on that one? All right, let's go to this next one. Go over here. All right, so I need to subtract across the top here this 5 over x minus 3 over x minus 1. Or x plus 1, sorry. So what do you guys get for the common denominator here? Very good. Yeah, so this x is a monomial. This is a binomial. These are different factors, so you would want one of each of those. You wouldn't just add a plus 1 in, because you can't add in by addition. It has to be by multiplication. Okay, so x plus 1 is going to be that common denominator. So the first fraction is missing an x plus 1, and the second fraction is missing an x. So if I multiply this, this is 5x plus 5, and then minus 3x across the top, which is going to give us, let's see, 5x minus 3x will give us 2x plus 5. And then I'll write that over, x plus 1. Okay, so that simplifies this numerator right here. And then that is divided by 1 over x plus 1. So that means I'm going to be doing 2x plus 5 over x plus 1 times x plus 1 over 1, because I want to flip that. So my x plus 1's can cancel. Can I cancel anything else? Cannot cancel the x's because this 2x is attached to the plus 5. So when it's attached with a plus sign, it is not singular. If this was just 2x and that was gone, like that would be fine. But because of the plus 5, this is a binomial. It is attached. So the answer there is just going to be 2x plus 5 over x, just like that. We can just ignore the 1.